All right. Here's some review help for Chapter 8 review packet. We're going to start with this question here. This is one of the first questions on your Chapter 8 review packet, and it says simplify. So when you are asked to simplify, you merely have to factor both numerator and denominator and then see what can cancel. And when I say see what can cancel, you're looking for the same thing top and bottom. Okay, the same binomial, the same monomial. If you're looking at numbers, see if any numbers can be reduced, things like that. So for this particular question, I'm going to look at the top. The top is two terms. Okay, so when I see two terms, like we've been talking about for every section that deals with factoring, when you see two terms, you think difference of squares, difference of sum of cubes, and GCF. So in this particular case, these are the difference of squares. Okay, difference of squares factors 4x plus 7, 4x minus 7. Okay, the bottom is not the difference of squares. It's not the difference in sum of cubes. It's simply just a GCF question. I can take a 2x out of the bottom. Okay, 2x out of here. If you take it out, think of it like dividing. 2x out of there is going to leave me 4x. 2x out of 14x is going to leave me 7, positive 7. So look at here. Now you see the same thing, 4x plus 7 top and bottom. That's something that you can cancel. Okay, so when I see the same thing top and bottom, we have a cancel party. Cancel them out. What's left on the top is 4x minus 7. What's left on the bottom is 2x. Okay? Do not try to reduce those. Okay? Those are not reducible. So don't do it. Okay? You can't reduce unless all three things, in this particular case, the 4, the 2, and the 7 are reducible. In this case, they are not because they don't have a common factor. So my answer here is just 4x minus 7 over 2x. Okay? Moving along. Now I'm asked to multiply. Multiplying is very much like simplifying, except you got more things to factor and more things to reduce and everything like that. So it's almost like simplifying because you just combine across the numerators and combine across the denominators, because when you multiply fractions, you multiply the numerators together and the denominators together, and you leave the numerators on the numerator and the denominators with the denominators, and you just cancel. So at this particular point, you factor. For the sake of time, I'm gonna kind of skip through the MAF process. So 2x squared minus x minus 3. I'm gonna factor that with my head. I know that 2x squared, you can only get that by multiplying 2x times x. Negative 3, you can only get by multiplying 1 and 3. So I'm trying to come up with some kind of combination here. So if I multiply 1 and 3, it's going to be negative 3. Positive 1, that's going to give me a negative 1x. So there's my factored version. On the bottom, that's the difference of squares. Okay. On the top there, what multiplies a negative 2 but adds to 1? That's going to be x plus 2, x minus 1. Okay. And then on the bottom, 2x squared. What multiplies the 2x squared is only 2x and x. I'm going to get x there, so I'm going to say, looks like 2 and 3, some combination. It's going to be positive 2 and negative 3. All right, so at this point, I know I went through that quickly, and you're like, okay, how did you factor that? I basically just did it in my head. Being a math teacher, I can do that. If you need to, do MAF, okay? MAF this, okay, go through the process. It takes a long time. For the sake of this video not taking 4 hours, I'm not going to go through the MAF, okay? That's something that I'm hoping you should be able to do at this point. If you have trouble, go back to the sections that deal with factoring, and I explicitly go through MAF, and you'll have some help with that. But for these problems, I'm just going to kind of factor it by hand in my head. So when I look here, I look for the same thing top and bottom. This is my cancel part. I got 2x minus 3 is top and bottom. I got an x plus 1, top and bottom. I got an x minus 1, top and bottom. And I have an x plus 2, top and bottom. Now, everything cancels. Okay, the typical answer that people make mistakes putting is 0. That's not true. When I divide something by itself, is basically what happens when stuff cancels. It's 3 divided by 3, 1. So when everything cancels, your answer is simply just 1, okay? So that would be the answer there. So that's multiplying example. Here's a dividing example. All right, when it says when dividing, take the reciprocal of the second term and then do the same as you would if you were to multiply. So it's the same thing. I'm just going to rewrite it first as the same exact thing. 3x squared minus x minus 2. 6x squared minus 5x minus 6. But I'm not going to divide anymore. I'm going to multiply and I'm going to multiply by the reciprocal. Okay, when you divide fractions, that's essentially what you're doing. Okay, so when I divide two fractions, you multiply by the reciprocal. So if you understand dividing fractions, which you may or may not, then you know that that's going to be how you do it. Okay, so now I'm going to factor all pieces, and then I'm going to see what reduces. So for this particular one, all right, so for these, I'm going to factor them, by hand or in my head. And if you want to do MAF, clearly these are a little bit more involved. So when I factor the top one, 3x squared minus x minus 2, I'm going to get x minus 1 times 3x plus 2. All right, and I FOIL that back, and I see that it does in fact give me the result. On the bottom, I got 6x squared minus 5x minus 6. The factor that, I get 2x minus 3 and 3x plus 2. Okay, and if you add those up, you will in fact get negative 5 for negative 5x as your middle term. And this one is a difference of squares, so that's just 2x plus 3 and 2x minus 3. And then the last one is 2x squared plus 5x plus 3. So that's going to give me two x plus 3 times x plus 1. All right, so the factoring is probably the hardest part about these. Okay, so it's taking the time to make sure you're doing those correctly is going to be where you're going to make most of your errors if you make any errors. So just make sure you know that the process involved is the same as multiplying. The hard part is just cancel or figuring out what everything factors to. So cancel party: 3x plus 2, 3x plus 2, 2x plus 3, 2x plus 3, 2x minus 3, 2x minus 3. X minus 1 and x plus 1 do not cancel. So my answer here is left on the top, x minus 1, left on the bottom, x plus 1. So that's my final answer, and that would be how you divide those two rational expressions. The next thing, adding and subtracting. Okay, when you add or subtract, you determine the least common denominator and make all terms have that denominator. Okay, so in order to do that, I have to first factor this bottom term. So this is what multiplies to 6 but adds to negative 5. Okay, and that's x minus 2, x minus 3. So I know that that bottom is x minus 2, x minus 3 already. The bottom of the second term, the denominator of the second term is x minus 3. So when I write this, I'm going to make both denominators be x minus 2, x minus 3 because that's the only thing that both denominators can go into. Okay? And when I make that the denominator, what I ask myself is, okay, what did I do? Okay, I made the denominator x minus 2, x minus 3. Well, the denominator here already was x minus 2, x minus 3, so I don't have to do anything else. Okay, the denominator here was just x minus 3. I added an x minus 2. You can't just add an x minus 2 to the bottom of a fraction. Okay, the denominator, you also have to add it to the numerator. So that's the tip there. Okay, because when you do that, it basically didn't change anything because I could cancel these out and you would end up with 4 over x minus 3, which is what you started with. Okay, but I don't want to cancel them out. I wanted it there so I could add them. So now I see it's going to be x minus 1 plus 4 times x minus 2 over x minus 2, x minus 3. On the top, I get x minus 1 plus 4x minus 8 over x minus 2, x minus 3. And I just combine like terms. So x plus 4x is 5x. Negative 1 and negative 8 is negative 9. And the denominator is still x minus 2. X minus 3. So the tip there is to determine the LCD. So the LCD is that. And that's the hard part because you're like, well, why is that the LCD? Well, it's because both denominators can go into x minus 2, x minus 3. Okay, both denominators, if I divided both denominators into x minus 2, x minus 3, it'd be okay. You would get no fractions or anything like that. So it's a little bit tricky, but the next one involves a similar concept, okay? So now you ask yourself, okay, change all the denominators using the LCD just like we did before. With an equation, though, you just then have all the denominators the same, then you just solve by setting the equation up with just the numerators because the denominators can cancel out. All right, so what is the LCD? Again, all denominators can be divided by x plus 2, and it would be fine, okay? I'm sorry, all all denominators can go into x plus 2, and it would be fine. So my LCD actually is x plus 2. So I'm going to rewrite this so that all the denominators are x plus 2. Okay, so here's the trick. If you got 5 as a term, because that is a term, you got to take that into account. You have to realize, okay, the 5 had a denominator of 1. I added it an x plus 2. So what I have to do is to take into account the fact that you can't just add x plus 2 to the bottom. You have to also add it to the top. Okay, the tricky part here, because now that all the denominators are the same, you can kind of just cancel them out. Okay, because if I multiplied both sides by x plus 2, it would just go away. Okay, the tricky part here is to know that negative right in front of that 3 minus 2x needs to be distributed. So if you forgot that, or you were wondering about this question, that's the trick. So when I distribute that negative, it's negative 3 plus 2x. Okay, so be careful with that. All right, so then I solve this equation. It's x minus 1, 7. X 7 minus 3 is plus 7. So then I'm going to subtract and add 1, subtract 7. So altogether I get negative 6x equals 8. So x is going to equal negative 4/3. Okay, not the prettiest answer. And if you didn't get that, probably it was that little mistake where you didn't distribute the negative. So I would say if I had to point anything out to this one, make sure that if there's a negative in front of a rational expression and there are 2 terms in the numerator, that you distribute that negative to each of the 2 terms. So be careful with things like that. Okay, hopefully that helped you with your chapter 8 review so that you can do better on your test. Ace it. Do good. All right.